Paper of the day is Tolerating File System Mistakes with EnvyFS. Paper proposed EnvyFS, an approach that harnesses the end version approach to tolerate file system bugs. Central to their approach is building a reliable whole out of existing and potentially unreliable parts, thereby significantly reducing the cost of development. They have also proposed the use of a single instance store to reduce the performance and disk space overhead of an end version approach. Subsist, a single instance store, is designed to retain much of the reliability improvements obtained from EnvyFS. They have built and evaluated EnvyFS for Linux file system and also shown that it is significantly more reliable than file system of which it is composed. With Subsist, performance and capacity overheads are brought into the acceptable range. As a fringe benefit, they also show that the end version approach can be used to locate local bugs in the file system. This picture portrays the end version file system in Linux as depicted in the paper. So here, this figure presents the architecture of a 3-version file system with X3, RiserFS, and JFS as the children. The core layer is EnvyFS. It is responsible for issuing file operations to all 3 systems, determining a majority result from the ones returned by the file system and returning it to the VFS layer. The optional layer beneath the file system, that is Subsist, is a single instance store built to work in an end version setting. It coalesces user data stored by the different file systems in order to reduce performance and space overheads. Looking at the contributions, authors have implemented EnvyFS and Subsist for Linux. Currently, EnvyFS employs any combination of X3, JFS, and RiserFS agile file systems. Through fault injection, they have analyzed the reliability of EnvyFS and have found that it can recover from a range of faults in nearly all scenarios. Many of these faults have caused irreparable data loss or unmountable file systems in the affected child. They also have analyzed the performance and space overheads of EnvyFS both with and without Subsist. They have found across a range of workloads that in tandem they usually incur modest performance overheads.